Alrighty, so welcome to this session of Lectures with Liddington. Today we are going to learn how to draw atoms. If we can learn how to draw atoms, we will get a better understanding of how they interact. The next thing we're going to talk about is how they interact, how they bond together and make molecules. Well, if we can draw them, we can better understand that. So let's take a look. The one thing I want to remind you guys from the start, atoms. We're talking about atoms here, and atoms are electrically neutral. So that means my protons, right, those are positive, and my electrons, those are negative, and my neutrons are what? Neutral. But because they are electrically neutral, that means over here, that means my protons equal my electrons. So that balances out that charge. It's important to know as we move on when we start drawing them. So one of the vocabulary words that we need to know here is valence shell. Valence shell, that's the outermost shell. Oh, okay, Mrs. Liddington, what is a shell? Well, with all of those electrons that are flying around the outside of the nucleus, they're contained in shells, just sort of like a candy shell. If you get those little, like the Lindt hard candies that are round, remember there's goo on the inside, different kinds of chocolates on the inside, and then there's a shell on the outside. That's what happens with the electrons, is they get contained in different layers of shells around the outside of that nucleus. Well, our valence shell, that's the outermost shell. That one's going to become really important in our next episode when we start talking about bonding. But we'll start working from the inside out, and that's how we fill our shells with our electrons, is we always start filling from the inside and we work our way out. So here on this innermost shell, I can fit 2 electrons. 2 electrons, inner shell. Each shell that comes after that, I can fit 8 electrons. In order to be full. Eventually you get to a point where there's just too many in too small of a space, and then they'll start repelling each other. So there is a cap for how many electrons can fit in each. So 2 on the inside, then I move out to the next shell and I can fit 8. If I fill that, I can go put 8 more in the next shell. Well, let's take a look. What does this look like when I take these pieces of information and put them together? Let's start here. This is my atomic number, as you might remember from our last episode. My atomic number tells me my number of protons. My mass number, or my atomic mass that's down here, this number is telling me the number of protons plus neutrons. Now, notice, right here I've got 12.011. That's actually the atomic mass. That's an average of all the different isotopes of carbon. We can't have 0.01 of a proton or 0.01 of an electron. So we're going to round this to the nearest whole number when we do this. So when we do our mathing here, we're just going to use 12 for our number of protons and neutrons. So I have 6 protons, and down here my protons plus my neutrons is 12. Hey, Mrs. Liddington, that's really great, except how do I figure out neutrons? Well, gonna have to do some mathing here. So I have my number of protons here is 6. Neutrons we're gonna figure out. Electrons we're gonna figure out in a second. But how do we get our protons and neutrons? Well, we take this number down here and we subtract the smaller one, the one on top. So I have my atomic mass, and I subtract my atomic number. And what I will get at that point is my number of neutrons. So I will take 12, subtract my atomic number up here, 6, and I will get 6. So I have 6 protons. I now have calculated 6 neutrons. And how do I figure out how many electrons? Oh, it's an atom. It's electrically neutral. So I have the same number of protons as I have electrons. So boom, 6 there too. So let's draw it. Let's see what it looks like. So I'm going to draw a circle in the center for my nucleus. And instead of drawing all those little dots, the protons and the neutrons, boo, 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 I'm just going to write P equals 6 and N equals 6. So I know in there I've got my 6 protons and my 6 neutrons. My electrons now I have to fill from the inside out. So this shell that's closest to my nucleus can only fit how many? 2. I can fit 2 in here. Boom, boom. So I put my 2 electrons in. Now I keep going. Put my next shell there. And I look, okay, so I have 2 so far filled in. 3, 4, 5, 6. There's my carbon. That's what an atom of carbon looks like. Let's take a look at some others. So, carbon is one of the most common elements in all living things. The top 4 are carbon, hydrogen, oxygen, and nitrogen. Let's take a look at what they look like. 1 proton. Well, that rounds down to 1. So 1 minus 1 is 0. So that's 0 neutrons. That's not super exciting, is it? Well, my protons are equal to my electrons, rather. So I have how many electrons? Just 1. 1 little electron. But that 1 little electron ends up being super useful when we start building living things. All right, oxygen here. 8 protons. 15.99. Am I going to use 15? Nope, I'm going to round up to 16. So protons, I know I have 8. Protons plus neutrons is 16. So I take 16 and I subtract my protons of 8. And I get 8 neutrons. Here I go. I got 1, 2 electrons in that first shell. I'm going to keep going. So I've got 1, 2, 3, 4, 5, 6. And then you go back to the top. It's just like cardinal directions, but you get 2 for each section. 7, 8. So there's 8 total electrons, 2 in that inner shell and 6 in that outer shell. All right, nitrogen, last one. I've got 7 protons, 14.0. I'm going to say that that's 14. So protons is 7. Neutrons is 14 minus 7, which also equals 7. There's my nucleus, my inner shell, 1, 2. My next shell, I drew this a lot taller, huh? So 1, 2 electrons, 3, 4, 5, 6, and 7 electrons. Notice we've got a pretty decent pattern here, that we have 8 protons, 8 neutrons, 7 protons, 7 neutrons. That happens frequently in these smaller elements, but once you start getting to bigger ones, you'll see a lot more differentiation. But that is how you draw atoms. So let's practice some more.